Hello student, my name is Kalal from Alja Institute of Engineering and Technology. Welcome to my online lecture series of Basics of Automotive System. So today I will discuss a new topic or new unit, that is chapter number 4, that is a drive line. Okay. Chapter number 4, it consists of very small topics. Okay, in that we will discuss about the propeller shaft, slip joint, and universal joint, constant velocity joint, heavy duty tandem axle cylinders. Okay, this all types of we will discuss the drive, considering the drive line. Okay, the chapters which considers in drive line, that is a propeller shaft and a universal joint and our constant hook joint and constant velocity joint and slip joint. Okay, so let me discuss one by one and each component. So this is a very small unit of our syllabus. There is a basics of automotive system in our syllabus, and this is very small and very easy topic, not to require much more knowledge of to understand these topics. Okay, let me understand one by one. First, let me understand the proper introduction about the propeller shaft. Okay, that first we consider about the what is the drive line. Drive line is nothing but the component, which is a group of component which is used to transfer power, or we can say drive, to rear axle. It is a group of part connecting the transmission with the drive wheel. It consists of a drive shaft called universal joint, constant velocity joint, and half shaft. Okay, that is the our drive line. So the definition already written here. It is the group of parts transmission with drive wheel. It consists of propeller shaft, also called a drive shaft, universal joint, constant velocity joint, and slip joint. So let me understand what is the shaft. Okay, as this has to withstand torsional load, and whenever torsional load and by twisting is there, that time torsional load is coming while rotating any component, or when shaft is rotating, that time torsional load is comes on that shaft, or we can say twisting load. It is usually made of tubular cross section. The shaft which is made of tubular cross section, it also has to be well balanced to avoid whirling at high speed. Whenever the speed of the shaft is his resonance speed of this shaft is equal to the natural speed, that time whirling of shaft is this phenomena occurs, and the shaft may be very breaked or broken away, and it is very harmful for the vehicles. Okay, the shaft are made of steel, aluminum, and composite material. Okay, next is universal joint. One or two universal joints, depending upon the type of rear axle drive used. That depends on the which type of rear axis drive we used. And according to that rear axis, we used one universal joint or either two universal joint. Okay, like Hotchkiss drive, if you use that time two universal joint is used, and if we use a tubular type of rear axle drive, that time we use only one universal joint. That is depend on the rear axle drive. The universal joint account for the up and down movement of the rear axles when the vehicle is running. That means the function of the main function of the universal joint is nothing but it is used to transfer a power, or we can say torque, at a certain angles, like at up to 18 degree, angle, the power can transmitted from one place to another place. Okay, it is a joint. Okay, and next is slip joint. Depending upon the type of drive, which type of drive we used, one slip joint may be there in the shaft. If Hotchkiss type of drive we use, that means slip joint is there, and if tubular type of drive we use, slip joint is not present in that shaft. Okay, this serves to adjust the length of propeller shaft when demanded by the rear axle movement. Whenever the rear axles will move up and down, that time propeller shaft is also move up and down. That time slip joint, by using of this slip joint, the shaft will adjust itself. Okay, the length of propeller shaft will adjust itself by using of this slip joint. Okay, so these are the function of universal joint, shaft, and slip joints. Okay, these are our propeller. It is our propeller shaft. In that video, different component we used. This is our slip joint. This is our yoke this is yoke, and this is total propeller shaft. This is spider or arm, and this is slip joint. So this is our diagram of that propeller shaft assembly. So let me understand the what is propeller shaft. This is the engine, and this is transfer unit, or we can say gear mechanism, and this is gear shaft. Okay, and the power is coming from this gear shaft axis to this propeller shaft. This is our propeller shaft, and this both end of the propeller shaft is connected with this two universal joint. This is universal joint, and it is also a universal joint. Why universal joint is connected? Because it can transmit power at angle. This angle is made here, and similarly angle is also made here. Okay, so by using of this universal joint, power can transmit at an angle, or angle is permitted up to 18 degree, and this it is our differential mechanism, and this is rear axles. Okay, so power is coming from this engine to this hooks joint, and it transmit to the differential mechanism with the help of this propeller shaft. And propeller shaft is nothing but it is a hollow tube or a hollow shaft. Okay, so it can easily transmit power from this engine to rear axles, okay, through differential mechanism. So in our this chapters we will discuss about this universal joint, propeller shaft, and slip joint. Okay, so different components which is used in the propeller shaft. This is shown in the diagrams. Okay, this is flange yoke, or this is journal, and this is flange yoke. Snaping and roller bearing is here, and oil seal to mountain on that journal. And this is our yoke system, and the fixed yoke, and two types of yoke is there: fixed and movable yoke. It is our slip joint to adjust the length of propeller shaft, and this spline on this slip joint spline is provided, and it internal spline is provided in this yoke, and it is fitted in that here with the help of cork, gasket, and dust cape. Okay, or it is our main propeller shaft, and another yoke is provided here, and this is also similarly the same component is like here, and flange yoke is provided here, and lock plate is here. So these are the main component which are used in a propeller shaft. Okay, so you can easily draw in the your exams easily. Next is a propeller shaft function. The propeller shaft is used as a driving shaft to join the output shaft of the gearbox with the differential unit in the rear axles. Okay, we already understand these things in a previous slide. Okay, the rotational motion of the gearbox main shaft is transferred to the differential unit for the rotating the driving wheel. Mainly torsional load act on the propeller shaft because it is a rotating part, and it rotates with the help of the engine shaft, or we can say gearbox shaft. That's why it is a torsional load comes on the propeller shaft. Hence it is made of tubular cross sections because inertia is more, and it can easily bear by the torsional load compared to the solid shaft. That's why we use the tubular cross sections. To prevent the turbulence generation at high speed, it is preferably perfectly balanced. Okay, to prevent the turbulence which is generated at high speed, it is perfectly balanced. The function of universal joint. The universal joint is provided to transmit the power at changing angle of the propeller shaft while vehicle is running. Okay. Next is slip joint. Slip joint is provided with the propeller shaft to take care of increases in the length of propeller shaft while vehicle is running. Propeller shaft take power from gearbox output shaft without making any changes in the power. That means it can take power from the gearbox, and without any loss of power, it transmit the same to the input pin of the differential unit. That means the power, whatever power is comes on the gearbox shaft, which is taken by the propeller shaft, and it same amount of that power is transmitted to differential mechanism, or we can say bevel pinion of differential unit, from where power is transmitted to drive wheel through rear axles. Okay, so it assume that no power losses occurs in that propeller shaft. The function, okay, to accommodate the change in line level between the gearbox output shaft and differential input pinion shaft. Next is construction of the propeller shaft. The propeller shaft used to transmit the power from the gearbox output shaft to the differential with tubular cross sections and one or two piece construction. Okay, let me understand the construction of the propeller, how it constructed like propeller shaft. The two-piece propeller shaft is supported at the center by the rubber mounted bearing. Okay, and that over the shaft, the rubber is mounting over that on the bearing. Okay, the propeller shaft should be rigid enough to absorb twisting action due to driving torque and the torsional shock. The torsional shock also comes on that shaft that can be absorbed by that propeller shaft. So in such a way that the design of propeller shaft that can absorb by the twisting stresses, or we can say torsional shocks. Okay, it should be also capable to resisting the vibrations. Okay, due to unbalanced load or unbalance of the engines, the vibration are comes on that propeller shaft. That is enough to design that it can resist the vibration. Okay, tubular propeller shaft is generally used because why tubular propeller shaft uses, so it is because it lightweight. Okay, it can resist misalignment also, it has also good torsional strength, it provide less resistance to change angular speed cause when hook type coupling is used, or we can say hook joint is used. The propeller shaft is running faster when overdrive is used. That means the propeller shaft, the speed of the propeller shaft or a running is more in a overdrive system is used, as it should be produced as per required design specific and good limit of balance. That means according to design, according to speed, according to our drive system, the propeller shaft can be designed. Okay, next, vibration of the propeller shaft. The vehicle having bigger wheel base need long propeller shaft. Long propeller shaft generated whirling by bending its center. That means if whirling is achieved, that means the shaft may be bent, or bending occurs in that shaft. In such condition, resonant vibration are produced in the body, hence along with the whirl and vehicle body also vibrate. That means when it occurs, the speed of that propeller shaft, the resonance at resonant speed, that is equal to the natural vibrations. Okay, or we can say natural speed, that is the vibrations will become in that propeller shaft. For the resonant frequency of the propeller shaft, there are two groups, the main factor producing the vibration. The two factors are there: factor related to the propeller shaft and factor related to vehicle body. Let me understand factor related to the propeller shaft. The shaft diameter and length, that is depend on the propeller shaft design. The balancing assemblies and shaft joint, bending resistance of the shaft. Okay. Next is factor related to the vehicle body, shape and type of the body structure, location of the body structure parts, engine transmission mounting, spring, bushing, panel insulation, by clamping, quality of driving shaft vibration. That is the all the factors on which vibration, or we can say whirling of the propeller shaft, that depends, and vibration occurs in the propeller shaft. That is the all these parameters on which propeller vibration of propeller shaft depends. Next topic is a universal joint. A universal joint allows the driving torque to be carried through the two shafts that are at an angle with each other. That means power is transmitted at some angle. We use the universal joint. That is the main function of the universal joint. A simple universal joint consists two Y-shaped yoke. Okay, two Y-shaped yoke like this. Okay, two yokes like a Y-shaped yoke that we, one is like this and another is like this. Two yoke is there, and in between one members like arms, four arms like these members. Okay, which is inserted in between these two, so that it can transmit a power at some angles. Okay, the forearm of spider are assembled in a needle bearings in two yokes. Okay, revolutions, that is the function of that needle bearing. Okay, these are the our universal joint. These are two universal joint in used between these three shafts: shaft 1, shaft 2, and shaft 3. And two, the function of two universal joint is to reduce the difference of speed. Whatever speed is comes here, that total speed is transmitted to rear axis. That's why we use the two universal joint. This is one universal joint is used here, and a simple universal joint does not transmit the motion uniformly. Okay, The simple universal joint, this is our simple universal joint. It is not transmit the motion uniformly. That means at constant speed the motion cannot transmit. At some position the motion or speed is more, or we can say angular speed is more, and at some point or at some angles the angular speed is minimum. At four position it will maximum and in minimum. Okay, so because of these two universal joint are used vehicle, one between the gearbox and propeller shaft, and another between the propeller shaft and the differential pinion. This is our shaft and it is another shaft, and two yokes are here, and between cross piece R is provided. So we use the constant velocity joint. Constant velocity joint is nothing but two universal joints are used to getting equal motions, or we can say equal angular speed. Okay, equal angular speed between rear axles to engines. Okay, the constant velocity joint, also known as a homokinetic or constant velocity joint, allow a drive shaft to the transmit power through a variable angle, that means 0 to 360 degree at constant rotation speed. That means speed is constant without an appreciable increase in friction or play any wear and tears. Okay, and speed is a constant at variable angle, or we can say at any angles. They are mainly used in a front wheel drive, and many modern rear wheel drive cars with independent rear suspension typically use of constant velocity joint at the end of this rear axles half shaft, and increasingly use of them on the propeller shaft. Okay, constant velocity joint are protected by a rubber boot. A constant velocity gator, crack and splits in the boot will allow the contaminants in which would cause the joint to wear quickly. So these are the constant velocity joints. These may be conveniently classified under the following headings. That means constant velocity joint also classified in that double hook joint is also known as constant velocity joint. Reservoir. There is a practical CV joints. Okay, V's, tracta and tripods. Okay, in which two universal joints are used, but the angle made at here which is remains constant, so that we use a uniform speed. Okay, another joint is that slip joint. Slip joint is attached to the driven yoke in order to the increase and decrease the length of propeller shaft. Okay, it has outside spline on the shaft and matching the internal spline and matching hollow shaft or yoke. When assembled in this spline, cause the shaft to rotate together while they can move back and forth. This change the length of propeller shaft. Let me understand this slip joint how it works. Okay, this is the working of the slip joint, and here internal spline is in that shaft, and also external spline is provided here. Okay, so whenever rear axles is move up and down, that can adjust the length of this propeller shaft. When it is upside and it is down, okay, the length of this propeller shaft is adjusted automatically because we use the slip joint here. Okay, this is slip joint. Slip joint is by providing the spline on the shaft. Got it? These are the slip joint. Okay, it is our universal joint. It is also universal joint, and here propeller shaft, and it is our slip joint to up and down movement that it can balance easily, and length of this propeller shaft may increase and decrease. Next is tandem axle drive for the heavy vehicles. This is the theory related to tandem axle drive, and let me understand this theory for your exam point of view, because of no any other books it is there. Okay, this is taken from the J. Munni books. Okay, so these are all the theories. Okay, so let me understand the propeller shaft. Propeller shaft is used tandem axle heavy drive. There 6x4 vehicle we use. The 6x4, that means 6 wheel is present and 4 power is transmitted to this 4. 1, 2, 3 and 4. So power is coming from that engine to here, and it transmit to in that both 50% power is transmitted to in this two wheel, and also 50% power is transmitted to these two wheels. Okay, with the help of uh, heavy duty axles, or we can say tandem axles. In that we use two differentials, differential 1 and differential 2. So this for example point of view, you can make this diagrams. The power is coming from here and it is transferred to through drive to this regular drive. Okay, so it is used in that tandem heavy duty axle. Another one is type B, where we use the gearbox, or we can say transfer case gearbox we used to transfer this one. The power is coming here and transferred to here, and 50% power is transmitted to here. But sometimes what happens, this wheel is going to muddy, or we can say it can be jammed. So power is totally transmitted to this rear wheel, so it can easily comes escape out from that muddy surface. Okay, so that's why we use another differential mechanism is here, or we can say third differential mechanisms. Okay, this is nothing but our third differential mechanism in that case. But what happened in the type B figure? Okay, let me read type B figure. The propeller shaft connection to leading axles could be made at an upper driving head. This facility provided to convenient through the drive connection to an angle coupled shaft, which is transmitted drive to the conventional spiral bevel gear set in that trailing gear. But this tandem axle cylinder, firstly made by the American firm as a Goodyear and tire and rubber in 1984, it was early recognized that the driving and indeed suspension arrangement for the two-axle tandem possessed certain problems. It was be evident that the conventional bevel gear final drive does not readily lend itself to tandem axles unit. So it is not practicable to provide a coupling shaft directly between the driving pinion of leading and trailing axis. That's why we use the two differential mechanism, and between two propeller shaft used, and 50% power is transmitted to this rear axis and 50% is this trailing axis. Okay, this is leading axis and this is trailing axis. So this is our heavy duty tandem axis. Another is a drive lines for the public service vehicle. A public service vehicles, the which type of drive line we used in a public service vehicle, the different arrangement for drive line, which type of drive we used in a public service vehicle, that is summarized in following: offset front engine gearbox is one type of drive line, amidships engine and the gearbox, and another is rear engine and gearbox. These three types of drive line we used in the public service vehicle. This arrangement is early represented mean of obtaining increase in head clearance in center of gangway of the double-deck buses. Okay, this is usually in a double-deck buses. For this purpose, the engine, gearbox, propeller shaft, and final drive unit of the rear axle were offset in there entirely towards the near side of the vehicle. Let me see in that figure the offset front engine gearbox. Another is the amidshift engine in gearbox to provide as flat as possible a floor area suitable for forward control and one-man operation of single-deck buses, either on vertically or more especially in horizontal disposed engine. And gearbox may be carried amidshift beneath the chassis frame. The single-piece propeller shaft, slightly angled across the vehicle, is then all that necessary to transmit the drive to the rear axle. So this is in the amidshift engine and gearbox. The third one is the rear engine and gearbox. Clearly, this particular layout offers a low flat floor area, and for both single and double deck buses, together with the greater versatility in choice of locations for passenger entrance. So the first one is our offset front engine gearbox. It is offset from this here front engine, and its power is transmitted to rear axle. The differential and these are offset. So first one is the offset front engine and gearbox. Second one is the amidshift engine and gearbox. Amidshift is that is the engine is in midway between, not exactly mid. Here is engine and power is transmitted to here, so that the shaft is less length of shaft, and it transmitted to differential mechanism. Another is a rear engine gearbox and longitudinal, or here is transverse. When engine is put it like cross to body, that time it is known as a transverse, and it is a longitudinal. But is the rear engines, and here rear engines fitted in back of the vehicles. So this both C and B D diagrams is a rear engine gearbox, but in one figure C, that is a longitudinal, and in figure D, that is a transverse engine mounted. So these are the our public service drive lanes. So our chapter number 4 totally completed. If you have any doubt, then ask me. Thank you so much.